Recursion Lesson 1. First, we can start with the math. This is a geometric sequence. Then, first term is 1 and common ratio. To get the second term, I need to multiply 2. Third term, I need to multiply 2. So to get the third term, starting from the first term 1, I multiply 2 twice. If I want to get 8, I need to multiply common ratio 3 times. Then for fifth term, I need to multiply common ratio 4 times. So you can think about the explicit formula as a sub n. Nth term is first term 1 times common ratio 2 to the n minus 1 power. We can also think about the recursive way. Recursive way means it starts from the current. Look at only one previous. How can I get the current one? You can think just previous term a sub n minus 1 times common ratio 2 will be my current term, nth term. In the recursive, it's going the backward, so you have to say, oh, no, stop somewhere. So you have to give first term as a stop case. Another name, we can say base case. So we are going to write down the code about this. Now we are going to apply the compi Java. I'm going to make the recursive, I'm going to use a recursive formula. So my method is A. I need to find the nth term, so passing argument is n. I'm going to write the easy one first, the base case, first term. That means if n is 1, I'm going to get the term value as 1. So if n is 1, return 1. Else case will be the recursive case. A sub n minus 1 means do A with n minus 1 as argument. So A, passing A, the method itself, then n minus 1 will be passed as an argument. What you need to do to the previous term, 2 times, so 2 times A n minus 1. How easy? So you can say the stop case is base case, then if you call the method itself, that is recursive case. So recursive means basically you call yourself. So hello, am I here? Recursive method is one good thing is you can write the code simple. You don't really calculate a lot at the current position like explicit. You just need to think about one step back, that's it. Only one thing you have to keep in mind is a base case. So we are going to think about this code. This is exercise number 1. Number 1, you are going to identify the base case of this puzzle. That means puzzle is method name. You can find which one is returning default value. So you can say that both of them are base. So 2 base cases are there. Then if I combine, if base is greater than or equal to limit, the first argument is greater than or equal to limit, that is a stop case. Else case means recursive case. So in the recursive case, we can say opposite. So if base is smaller than limit, so first number is smaller than second number, we are going to calculate recursively. So we're going to have more steps. Okay, now let's see. If first number is bigger than second number, that means base is greater than limit, so that it's base case. Actually, first base case, so it will return -1. Then, if I do C first, because C is easier, puzzle 0, 0, that means first and second number, base and limit are the same. In that case, returns 1. How about 4, 7? First, base will be multiplied, so 4 times puzzle 5, 7. Then 5 times puzzle 6, 7. Then 6 times puzzle 7, 7. 7, 7 is 1. So 4 times 5 times 6. So actually 120. You can think about the recursive or the stack. Stack means you can think about you're gonna have the stack, the card stack. If you put the card stack on the table, then if you put one per one on the table, and you're gonna make a stack, when you put the last, it will be on the top. Then when you take the card from the stack, you're gonna get the top first. That means last you put on the stack, you're gonna get first. So last in, first out. It's the stack. Actually, Java is using index pointer to point currently the memory is hitting or which task. So index pointer is used to trace all the recursive, so all the track, all the stack has. Let's think about number 4. Show 1, 2, 3. Show is the method name and 123 is the argument. There's a if statement. Actually, if statement is recursive case. It's calling show. So show is now passing 12. There was one more thing to do. Actually, print 123 module 10 will be waiting inside of the stack. So it's on the bottom of the stack. Before I take out that print, I have to finish show 12 first, because show 12 was on the top. Then when I do show 12, I'm going to call show 1 first. Then printing 12 module 10 will be on the stack. Then you are going to call show 1. Then printing 1 module 10 will be on the stack. So next time, show 0 will be passed. 0 is not greater than 0. So it's gonna print 0 module 10. So I can say it like this way. It's tracing show 12 plus show 12 and print 3, and show 1 and print 2. Print 3, print 1, print 2, print 1 are waiting in the stack. Then show 0 will print 0. Then last in, first out. So 0, printing 0, 1, 2, 3. So it's gonna print 0, 1, 2. It's a print, not print line. You have to be careful with the print and print ln. But number 5. It's a printing first, so 3 will be printed first. Then you call show 12. So in this case, show 12 will wait. Then because the print is already done, show 12 is out. Now we are going to do show 12. You're going to print first, then show 1 will be wait. But printing is already done, so show 1 is out from the stack. So now you are going to do show 1. Then printing 1, then show 0. In the show 0, you are going to print 0. Number 7, you need to think backward. When I am in the n, what I'm going to do is just add 1 over n. That's it. The previous one is all of the sum of 1 less. So sum of n minus 1 plus 1 over n is what you're supposed to do. But if I just use 1 over n, there is a problem. Integer divided by integer. It will return only 1 or 0. So I have to change it to the decimal, 1.0. Also, this one is double type as a return type, so it's okay. Then you are going to pass n minus 1 to the sum. Now let's see the base case, stop case. The last one, first one is 1. So I know return 1. When I'm going to return 1? When 1 over 1 is 1, so n equal 1, I'm going to return 1. So it's going to be base case. Number 8. If I pass 5, what will happen is 1 plus count 4. Count to 4 will do 1 plus count to 3. Count to 3 will do 1 plus count to 2. Count to 2 will do 1 plus count to 1. Count to 1 is 1 because it's a base case. So when I pass a count to 5, I'm going to get 1 plus 1 plus 1 plus 1 plus 1. So return is 5. That means we can just say this one is counting. So if I come back to the slide, I can say like this way, it counts the levels of recursion. It is just returning the same number, but that is actually how many recursive call made.